Our next talk comes from Vuyisile, and you'll be talking about PyPI in a box using a Raspberry Pi as a portable PyPI server.
Thank you. Thank you. Before I get into the talk, I'd just like to take a minute to thank the organizers of the Ubuntu Summit for inviting me here. I'm new to the Ubuntu community, and it's been a blast. The past 3 days have been good. It's been good talking to many of you and sharing questionable Czech drinks after hours. So that's been good. I am a DevOps engineer. I work for a company called the Migas Group, and I've been involved in open source and open source communities for a while now. I was, for a long time, a core contributor to the Mozilla project. I used to work in QA, testing pre-release builds of Firefox. And during the days of Firefox OS, I led a translation team to translate Firefox OS into Ndebele, my native language. But unfortunately, the Firefox OS project died, and so I stopped contributing to Mozilla. Since then, I've learned to code in Python, and I support the Python communities in my area. So I'm a Python developer by profession, and I'm a member of the community, the Python community in Zimbabwe. So I'd like to talk to you today about some of the problems we face in my community in Zimbabwe, and tell you about a solution that I built to address some of the challenges. And then in order to understand how this solution works, I'll take a moment to explain how packaging works in the Python ecosystem, for any of you who may not be entirely familiar with Python. But yeah, let's get into the community. So this is a picture taken at the most recent Python conference we held in Zimbabwe. We have a small but booming community, very enthusiastic people, and many of them are here today. The Python language is gaining a lot of traction in the country and strong interest because of it's been taken up by academia. There are some university programs, cybersecurity programs being taught entirely in Python. And one of the largest supercomputers in Africa is in Zimbabwe. It runs open source software and Python. So the community is growing, and there's a lot of interest in that. And we also have community members who've taken positions of responsibility in different Python software foundations. Anna, who introduced me, is president of the Django Software Foundation. Django is a popular web framework written in Python. Where's Marlene? Marlene over there is a former director of the Python Software Foundation. So we have a very nice, vibrant community. But we have some problems. These problems are very difficult to solve, and you here in Europe may have the same problems. The first one is energy problems. Now, because of the changes in climate and the weather, we've been getting erratic rainfall over the past few years. And now Zimbabwe's biggest source of power is a hydroelectric power station. So because of the erratic rainfall and lack of maintenance over the years, power generation units go down frequently. So we have frequent blackouts. So that's the first problem. Second problem is, this is I think a problem that's an Africa-wide problem, is we have poorly developed internet infrastructure. Now Africa as a continent is connected to a number of undersea fiber cables, but Zimbabwe is landlocked and we don't have enough inland fiber network connections from these undersea cables. So because of that, internet access is expensive and not very reliable. We use microwaves, mobile, and very high latency, slow, expensive internet connections. And so whenever we have meetups like the one I showed you, the internet is almost always bad. Yeah, so that can't be helped. Now, this makes running workshops where attendees need to download packages live very difficult. Now, what we usually do is we have delegates download the software beforehand, but not everyone can do that. So I built a device that gives developers offline access to a resource they need, whether they have power or internet. And it's built on a Raspberry Pi. So I created a mirror of the PyPI, I'll explain what that is, on a low-cost, low-power Raspberry Pi that allows you to serve Python packages and other content offline. So the Raspberry Pi lends itself very well to this task, as I'll show you. So let's take a moment to discuss how packaging in Python works in general for those of you who may not be familiar with the process. So this is a pic screenshot of the Python package index website, or PyPI. PyPI is the official third-party software repo or index for Python packages. So if you're a package author and you wanted to share a package with the community, you'd put it here. And the last time I checked, it had more than 400,000 packages, you know. And the tool used to install packages from this index is pip. It's a package manager. Similar to apt, npm, gem, or winget in Windows. It is the de facto package manager for Python. It allows you to install and manage libraries and dependencies from PyPI. But the nice feature about it is it uses PyPI as its default source of packages, but it can be configured to install packages from other sources, local or remote. And then we can take advantage of this feature to install packages mirrored onto a device like this. So you can download, install, uninstall, build, manage. So that's what the pip help file, help man page looks like, help page looks like. All right, so let's suppose you wanted to install a package like requests. Requests is a popular HTTP library written in Python. So the command to install requests is pip install requests, right? So when you run that, pip will go to the pypi.org website, search for a package called requests, figure out what dependencies it has, collects them, and installs them. Now, this process is pretty simple, fast, and straightforward. And it works virtually all the time if you have internet access, right? So this is why we have to use a clone. Now, some people may ask, I mean, why do that if the process works, right? And some say, oh yeah, this is a solution for poor countries, but that's not entirely true. While it's true that if you have expensive or unreliable internet or poor or limited access to power, this would make sense. But it also makes sense for server admins who need to update or install software on servers that don't have internet connections for whatever reason. If you want to save bandwidth when installing or updating Python software on a network of computers, you could use an offline mirror like this, right? But at the end of the day, creating your own mirror means you always have access to the Python packages you need. All right, so let me walk you through the general steps to follow when creating a PyPI server. Now, the easiest way to create a mirror is just to simply download the packages locally and point pip to the folder that has them. That works, but if you want to share the files on a network, you need some setup. So first thing you need, Raspberry Pi. And for those who may not be familiar with what a Raspberry Pi is, it's a small computer the size of a bank card, and it's lightweight, affordable, it's portable, and runs on very little power. You can run this using a power bank. So once you have the Raspberry Pi, you install an OS on it, like Ubuntu, and then you mirror the Python packages onto it, create a wireless access point, so you turn it into a hotspot, install some software to manage DHCP, to IP address allocation, and then a web server to serve up the packages to connected clients. So the first there's a number of tools you can use to clone the packages. I use a tool called Mini Repo because, as you know, space is limited on this device. So Mini Repo allows you to download a selective clone of PyPI. You can configure it to specify exactly what type of packages you want. So you can limit your clone to, say, Python 3.10 packages or Python packages that run on ARM or something like that. So Mini Repo will clone PyPI packages for you onto the device. And then the second one is PyPI server. So PyPI server reads the files on the disk and indexes them. This makes it easy for pip to search through the files quickly. And then thirdly, I used Nginx. Nginx is a good production-grade web server that can handle a high load. It can cache requests, so that improves performance as well. Right? So to clone the content of PyPI, you install Mini Repo, pip install Mini Repo, configure it, and run it. Once you have that, you do the same, install PyPI server, run it and point it to the location where you downloaded the packages, and then you set up Nginx. Nginx is a little more complicated to set up. This is what an Nginx configuration would look like. The most important thing here is I created a cache so that when you install a package, next time you do, Nginx remembers where it found it, and it results in significant speed-ups. So Nginx, you set it up as a reverse proxy to PyPI server, and you can also give your server a DNS name. In this case, I called mine cheeseshop.com. Cheeseshop is the code name for PyPI server. So you add that to your local host file, and you can reference the server using any host name you need. So at this point, you've cloned the packages, you've set up an index using PyPI server, and you've set up a web server that will serve the content over HTTP. The next thing to do is to create a network. This will allow multiple clients to connect to the Raspberry Pi and then install packages from it. So we need two things, DNS software and DHCP software. These two pieces of software will turn the Raspberry Pi into a server, a network server, and I used these two software. Host APD is what you use to turn it into an access point. DNS mask handles the DNS and DHCP. So once those two are installed, you can configure them. So this is a typical config to make a wireless network. You specify the interface, then you give the network a name, set a password for it, and then once you've done that, the next is to give the interface a static IP. Since you're setting it up as a DHCP server, that's how you do it. So I gave this one a .1 address. And then the next step is to configure DHCP. This specifies which wireless adapter to use, the IP address it should listen on, and what IP address range you want to assign to connected devices. Now, I've never really tested this, but I think a Raspberry Pi can handle 30 connected devices or so. It could be more. I've never really tried it. So now you have a mirror, you have the web server, you have a network, right? So the next thing to do is to actually install packages from the offline server. And this is how you do it. You do it by adding a index URL flag to the pip install command. So it's pip install index URL package name. So if you were, say, installing Django, it would look something like this. Now, if you're doing this without an SSL cert, you need to add this trusted host flag. But this is what it would look like if you were installing Django from a device like this. Now, it's possible to, if you run this a lot, you can add the additional flags into a config file so that you don't always have to type in the additional index URL flag. So this approach to serving up packages is nothing new. I mean, it's software that's being, it's content that's being served by a web server. So it could be applied to more than just Python packages. You could use the same concept to create a local clone of apt, for Ubuntu packages. You could use it to create a clone of Wikipedia, Stack Overflow. Any content that can be served up over HTTP, you could do this. So I'm interested in talking to many of you about how this could be improved. If you have any ideas, I'm all ears. So yeah, do you have any questions? Oh, sorry, before you ask, if you're interested in this, I have an article that goes through all these steps at that website, bit.ly/PyPI_inbox. There's a blog post I wrote about this.
Thank you very much. I've actually seen your PyPI in a box in action, so it really does work. And my use case is a bit different because I don't have the kind of problems you're trying to solve, either of security or lack of internet and so on, but I do a lot of work that involves repeatedly pulling stuff down from PyPI, and it just seems really wasteful that I'm going all the time over the internet to pull down this stuff. And if I could have something that cached them so that the 10th time I'm pulling them down, it's using the cached version for the last 9 times, that would be a bonus. And could I use...
Sorry, what was that? The last one?
Well,
yes,
could I
you
use
could.
this for
You could.
Yeah.
So what you could do is if you wanted to, you could build this, or you could just clone PyPI onto your system, and then point pip to, you could add the default Python package index as a secondary installation source. So whenever you install packages, you install from a local mirror, and whenever it doesn't find the package, that's when it would go over the internet. So you could configure pip to do that.
Because I don't want to download the whole of PyPI unnecessarily, I only want to...
Okay, I'm not sure if there's an automated way to do, to cache the packages you need, but you could download the packages you know you definitely need and cache those manually, yeah.
Hey, thanks for the talk. Since I'm a network engineer, I could probably help you out with the problems you're facing about the URL you need to specify. You could redirect the DNS requests since you're the DNS and the DHCP in this network, you could simply redirect the requests to a local via Nginx, and then you don't need to specify the URL for accessing it. That would probably make it easier for your students to access it.
Definitely, yeah.
We catch up afterwards.
Okay, thank you.
Thank you for your talk. You think this solution can be also hosted in your local machine, or you are forced to host in under one? Because sometimes you cache your package, you download every time the same Python packages, and so it can be easier also traveling to already have locally this type of cache.
Yeah, you can host it on your local machine. I actually tested this on my local machine before I built this. Yeah.
Did you use it in real-life action at one of your conferences?
Yes.
How long does it last on a battery pack with providing internet and so on in practice?
This particular model of the Raspberry Pi is quite high-powered, so it really heavy on battery usage, but I'd say about 2 hours on a battery pack. And I've used it once or twice at a meetup. So I built this in 2019, and that thing that happened in 2020 that kept all of us at home happened. And so we haven't really had many meetups since then. But yeah, we've used it back home in Zimbabwe.
And thank you for your talk. And I know, what is your unexpected social impact for this development?
Sorry, I didn't catch that.
What is the unexpected social impact for this
Social
development?
impact?
Yeah, what is the unexpected? Where you do?
So the problem I was trying to solve here is attendees coming to meetups not being able to install packages. So if we have something like this, it means they can install packages, they can learn, they can build stuff. Yeah, yeah.
Children's or community?
Sorry?
For children's or women, what is the impact?
Oh, no, it's mostly just whoever comes to the events. Yeah.
Still have time for some more questions.
Follow up on that question about the social impact of this. And it's not directly about this, but you were asking about women and children and people outside the normal.
Social.
Are those people visible in the Zimbabwean community? Do they come to your events? Is this affecting them? Is this making a difference to them?
Yeah, yeah. So interesting you should ask that, because most of the events, not specifically in Zimbabwe, but in Southern Africa, most of the Python events have more female attendees than male attendees. Like in the Python Namibia community, I remember one time they had a conference where there was a 50-50 split between men and women. So this generally does help. And people like Marlene, she runs a non-profit that helps young women get into Python. So I believe this would be useful to them. But we haven't really had a chance to use it in a meetup. But many of the people who do come for our Python events are women. So I believe, yes, it would have an impact on them.
Hi there. Could this be productized enough that you could send just the box without yourself to an event and say, plug the box in and it will be all right?
It should be possible, because if we could write a build script to take care of the setup, then yeah.
Actually, I know a project from South America, where they have it's a different kind of project, but they need access to health information, so doctors and nurses and stuff like this need this, and they don't have internet access everywhere, so they build up almost the same box, but with Wikipedia and stuff like this, so they can access medical records and medical information. So this is absolutely possible to build in front of, because I built it myself at home. So this would be actually possible to build and send it somewhere, I think. And I built it with a Raspberry Pi Zero, so it's low power and pretty easy to do.
I learned recently from the Zoran brothers. Oh, is that what you want to talk about now? Okay, okay. Yeah, you go ahead.
Yeah, well, first of all, I wanted to mention with regards to the HCPS certificate, there's actually a project called MKCert that can provision local certificates, so it will work on the local network. So that can fix the whole issue with requiring the trusted host.
What's the product called?
MKCert.
Okay, okay.
I can tell you afterwards, after the talk. And then the other thing is, yeah, there's a few projects that can be run on the Raspberry Pi for providing content like Wikipedia, Khan Academy, TED Talks, and Stack Overflow. So there's Calibri that's being worked on actually by the Endless OS team that's also at the conference. And then there's also Kiwix. That's another project that provides access for offline content.
I just wanted to add to that, one of the handy things about Calibri especially is that it can actually set up the web server by itself in a very simple and user-friendly manner. So even people who aren't technically proficient, if you just drop off like a Raspberry Pi or a computer with that content and with Calibri, they can easily set up the server, and then local computers or smartphones can connect to it to get all of that knowledge, whether it's Wikipedia or TED Talks or other content like that.
Okay, thank you very much. I'll look into all those. I'm out of time. Thank you.